Ways to solve ratios, 13-3 Envision Math 6. In this topic, we are going to look at two ways to solve ratios. One of them is called cross multiplication, and the other one is called the rainbow method of multiplication. Okay, so the first method we are going to look at is our cross multiplication. And it's a very popular method. The products of cross multiplication are equal. Let's look at an example that illustrates it, because you can prove it this way. So if we have 3/5, and we're saying that is equivalent to 9/15. Well, first off, I can say, yes, I know this is equivalent because 9 divided by 3 and 15 divided by 3 would give us 3/5, and 3/5 equals 3/5. So I know these two ratios are already equal. So we are ending up with equal ratios, which is why they are called proportions. So let's look at what's happening when we are actually cross multiplying. We have our first ratio of 3/5, and we're saying that is equal to 9/15. So to cross multiply, we are going to multiply the 3 by the 15 and then the 5 by the 9. That's why it's called cross multiplication, because it makes a big cross there. So our next step in this process is to say, okay, that means I am doing 3 times 15, and on the other side of the equal symbol, I am doing 5 times 9. Now when we simplify this process, 3 times 15 is 45, and 5 times 9 is 45, and those two are equal to each other. So we have just proven that cross multiplication works. Now the second method was called the rainbow method, or you can think of it as insides, outsides. In this method, you are actually multiplying the outside numbers together, and then you are multiplying the inside numbers together. So the same principle applies. We will set up the ratio saying 3/5 is equal to 9/15. We're going to multiply the outside numbers together and then the inside numbers together. So that will give us 3 times 15, and we are going to say that is equal to 5 times 9. Now again, when we simplify this, 3 times 15 is 45, and 5 times 9 is 45. So we have just proven that this method works also. So let's see how these methods could be used to solve a proportion. If we are saying that 6/8 is equal to whatever this proportion is with p over 12. Using cross multiplication, I multiply the 6 and the 12 together, and the 8 and the p together. So that becomes 6 times 12, and we would say that is equal to 8 times p. Now, 6 times 12 is 72, and then we're saying that is equal to 8p. Now, if we look at the rainbow method, we would also have 6 to 8, and we would say that is equal to p to 12. I would multiply the outside numbers and then the inside numbers, which would give me 6 times 12 is equal to 8 times p. And then that, of course, simplifies to 72 equals 8p. Now if you look closely, you will notice that at this particular step, these two methods became exactly the same. It's just whether I set them up to multiply in a cross or whether I set them up to multiply them in a rainbow. So now on either of them we have 72 equals 8p. So when I have that, now I have an algebraic equation. So I'm going to try to get the variable alone, and I'm going to do that by using inverse operations, and of course I always want to use the golden rule. So right here I'm saying, okay, what's happening between the 8 and p? Well, they are being multiplied. So if I want to get the p on this side of the equation by itself, I'm going to need to divide by 8, which is the opposite or inverse of multiplying by 8. When I do that, these two 8's will cancel because 8 divided by 8 equals 1, and 1 times p leaves us with just p. Now, using the golden rule, I need to do the same thing on both sides. So I'll also divide 72 by 8, and 72 divided by 8 equals 9. So we are essentially saying that 6/8 is the same as 9/12. Could I verify that? Yes. I could reduce 6/8. I could say, if I divide these by 2, that is going to give me 3/4. And look on the other side. If I divide the 9/12 by 3, that would also give me 3/4. And those are, in fact, equal. Let's look at another problem and see both ways to solve it. So if Erin earns $34 mowing lawns for 3 days, how many days will it take her to earn 204? If we set this up for cross multiplication, we'll have $34 in 3 days, and we will set this proportion equal to $204 in we don't know how many days. So when we cross multiply here, we're going to end up multiplying 34 times the days, and that will equal 204 times 3. Now let's look at how we would set it up with the rainbow method. So you would have 34 to 3. I actually prefer to write the units below it when I'm doing the rainbow method. And we will set that equal to 204 to an unknown amount of days. We will multiply the outside numbers and then the inside numbers together. So that's going to give us again 34 times the days is going to equal 3 times 204. We have the same thing. Now on the both problems at this point we solve them the same way. So they would both end up being 34 days or unknown days is equal to 3 times 204. Well, 3 times 200 is 600. 3 times 4 is 12. So now we're going to use our algebraic solutions. We are going to look and say, the 34 and the d are being multiplied. That is the relationship between them. So to get the d alone, I'm going to need to get rid of that 34. To do that, I will divide by 34, since dividing by 34 is the inverse operation of multiplying by 34. And that will leave me with just a d on that side of the equation. Then I do 612 divided by 34. Well, I'm going to have to figure that out over here. 34 can go into 61 one time. When I subtract that, I'm going to get 27, and I will bring down my 2. So now I'm going to think 34 times 272. Well, I know 34 is close to 35, and if I double that, that's about 70. So I'm going to think how many 7s could go into 27, and I know 7 times 4 is 28, so I'm going to guess then that since 34 is half of 70, and I said 7 should go into that about 4 times, I'm going to think this 34 will go into it about 8 times. So let's try multiplying by 8. So 8 times 4 is 32, and 8 times 3 is 24. Add that 3 gives me 27. So that is the exact answer. So that will mean D will equal 18 days. Now keep in mind, I could still solve this the way we learned in our lesson 13-2. I could go ahead and take this 34 to 3 days, and I could find a unit rate, and then I could go from there to our target rate. But for this particular problem, to change this to a unit rate, 3 will go into 34. It will go in 11 times, and then I'm going to have a fraction, a third. And so then I'm going to have to multiply that fraction to get the 204. So in this particular instance, it is much easier to use either the cross multiplication method or to go ahead and use our rainbow method of multiplication. So now you try this problem and set it up both ways, with cross multiplication and with the rainbow method. If a 5-pound bag of food lasts the puppy for 15 days, how many pounds of food does the puppy need for 12 days? Go ahead and pause the video, and when you hit play again, the answer will appear. Okay, for cross multiplication, we set that up as 5 pounds for 15 days. There's a rate on the left. And p pounds for 12 days is our rate on the right. We cross multiply, and that gives me 5 times 12 equals 15 times p. On the rainbow method, we set it up as 5 to 15 is going to equal p pounds in 12 days. So we will multiply that, and we will get 5 times 12 is going to equal 15 times p. Now, since they are both equal at this point, we are going to go ahead and solve algebraically. Well, 5 times 12 is 60, and that is going to equal 15p. To get the p alone, I'm going to look and say, between the 15 and the p, that is being multiplied. So I'm going to do the inverse operation and divide, which 15 divided by 15 will equal 1, and 1 times p is just p. And then we need to use the golden rule and divide on the left-hand side. So 60 divided by 15 is 4. So that means that puppy needs 4 pounds of food for 12 days. Now go ahead and do your quick check and see how well you understood today's lesson.